The last video was pretty conceptual. We want good statistics, good samples, results that are reliable. But now let's get into some methods. In this video, I introduced the first two tools to draw conclusions from data, which is what the course is all about. First, as usual, more vocabulary. The analysis of conclusions of statistics can be broken down into two categories, descriptive and inferential. This is tricky, since both are about getting information from data. What is the difference, really, between a description and an inference? Well, this is how it works, so the distinction is a little bit subtle. Descriptive statistics are ways of describing, summarizing, and visualizing the data in a data set. They help to make sense of what the data is, and they're relatively direct. They're a way to show you what's there on the surface. Inferential statistics are more ambitious. They start with a hypothesis of a relationship between the variables in the data set. This relationship is more than just a description of the data, it's a mathematical connection hidden inside the data. Once this hypothesis is put forward, it is tested with a variety of methods to determine whether the hypothesis holds. It's a much more active process than summarizing or describing. For now, for this video, we want to just use the descriptive methods, and I'm going to start with describing categorical variables. Here's the data from the first video again. To remind you, the data measures whether or not patients had a stroke within 2 time periods separated into treatment and control groups. There are 451 patients in this data set. Just skimming through it, we can try and get a sense of how many had strokes and how many didn't, but that's not particularly precise. Instead, one of the things we can do is to make tables to summarize. A frequency table is a table that gives the total count for each value of a categorical variable. Remember that categorical variables are variables with some set number of categories, which could be anything the researcher wants. So a frequency table is just counting up how many of each category show up for this one particular variable. It's not fancy. In many ways, it's the first obvious thing to do. However, having a term, frequency table, to refer to this is still very useful. Even the straightforward thing like counting are well served by having a definition to refer to it. Note the total here. The total of a count should always add up to the number of cases, since each case has to fall into one of the categories. These counts could also be represented as percentages. The total is 451, so 405 divided by 451 is 0.898, or 89.8% of the 451. Likewise, 46 calculates to 10.2%. This is still called a frequency table. Total count or percentage are two ways of recording the frequency of each category in a categorical variable. Again, the total should sum up to 100% to make sure all of the cases are accounted for. This summary tells us that strokes occurred roughly 10% of the time over this variable, which was the 30-day time period variable. A frequency table just counts what happens with one fixed variable. A study, however, often wants to compare treatment and control groups. Those are different variables, so we now need to combine variables. This is a contingency table. More vocabulary again. Stats exist and move by its terminology. Taking this course seriously, again, means working on the terms, trying to internalize them. A contingency table counts the frequency of each variable when another variable is fixed. Here, the first column is the category of a categorical variable. Control or treatment are the categories in the variable group. Then, for each value of that variable, for control and for treatment, the other variables are counted. It's a setup again to do something that's pretty obvious. How many people in the treatment group actually had a stroke? How many people in the control group actually had a stroke? These are very natural questions. In fact, these are the central questions of the research study. But we need a name for this table again, as obvious as it might be. It's called the contingency table, since it records how other categorical variables are contingent on some fixed categorical variable. The totals are included on the right and at the bottom. The right is the totals in the control and treatment groups, and the bottoms is the totals in the stroke and no event variables. Adding them all up gives the check on the bottom right that we have accounted for all the possible cases. As with the frequency table, we can convert these to percentages. This is pretty valuable for interpretation, since the control and treatment groups might be of different size. Raw numbers might not be the best comparison, but percentages may be more honest. How are these percentages calculated? They're a percentage of the total for each category. So 5.7% is 13 divided by 227, not the whole 451. And 14.7% is 33 divided by 224. That's the correct ratio. What percentage of this group category, not all the cases, just the cases in this group, fall under this 30-day stroke, no stroke category? This is descriptive statistics. We are summarizing the data. 5.7% of the control group had a stroke within 30 days, and 14.7% of the treatment group. This study is looking pretty poor for the efficacy of stents in helping prevent strokes, and that's a reasonable conclusion from this display of data. You might be frustrated by how we've turned something pretty obvious, just comparing the percentages, into a formal structure with a technical name. And this is an understandable frustration, and one that is really common in learning statistics. The terms, calculations, and structures can often confuse and seem like they are getting in the way of a more common sense analysis. But they are necessary. We are going to build on these terms and structures, and we're going to need a way to clearly and precisely refer to them. So please stick with it. Work on the vocabulary, and try to connect all the new terms and structures to the pretty reasonable and straightforward logic underneath it all. Which group had more strokes in the first 30 days? Surprisingly, perhaps, in this case, the treatment group did, and by a large margin. And that's what we see by this table.